Hello everyone, this is a tutorial on the Rua Puzzle. The Rua Puzzle belong to the family of the jumbling puzzles. Jumbling puzzles are puzzles where usually an edge, but in this case a face, can move by 180 degrees only, like that. Or you can move usually two edges, but in this case two faces, by less than 180 degrees. And this opens up to a very peculiar move, which is called the jumbling move. This is a table of contents of this video for your convenience. In this video, I will propose a method for solving the Rua puzzle, which is based on very little use of setup moves, no more than 2 setup moves at a time, at a cost of performing a bit more times the algorithm. In the family of the jumbling puzzles, there are puzzles which are cube-shaped, like the curvicopter puzzles, which are edge-turning puzzles. There is also the edge-turning octaedron, which again is an edge-turning puzzle. And then we have the Rua puzzle. The Rua puzzle is a shape modification of the edge-turning octaedron, where edges go to faces, vertices go to vertices, edges go to the triangular shaped centers on the Rua puzzle, and then the big center triangles go to centers on the Rua puzzle. I will call them centers, although they don't like, so for me they're centers. And finally, the small triangular centers are missing. Jumbling puzzle which have a cube shape have orbits. This means that centerpieces move on orbits. If we want to switch a centerpiece from one orbit to another, we need to use the jumbling move. This also applies to the edge-turning octaedron, but only to the triangular pieces which are missing when we shape modify from the edge-turning octaedron to the Rua puzzle. This means that the Rua puzzle has no orbits, and in theory we can solve it without using the jumbling move. I don't know what is the standard notation for the Rua puzzle. However, with the puzzle in this position, I will call this face front, this up, back, down. Then I got 8 more faces left. I will call this right up front, this right up back, right down front, and left up back, and so on. You got it. Since this puzzle is very similar to the other jumbling puzzles, we can use and adapt algorithm from those puzzles to solve it. Our strategy will be to solve the center first, then we will solve the corners, and finally we will solve the triangular shapes. Okay, we are ready now, we can scramble it. The first thing to do is to give to the puzzle its original shape. This is quite an intuitive part of the solve. Here we go. Be careful, because in this phase the puzzle will become very quickly jammed and very difficult to move, and if you push it too much, pieces will come off very easily. Now that the puzzle is in its original shape, we can start the solve. Step number 1 is to fix the centers, and then we will fix the vertices. I've seen people doing the opposite. However, this is my method. So the first thing to do is to find two centers with matching color. That was easy, it's not always so easy, and put them together. So we need to find a green one and place it here. Now the green center is in the right position now, but we need to rotate it. We will rotate it anti-clockwise. So with two pieces to preserve on the down face, we need to rotate this anti-clockwise. So right front, right back, back, left back, left back, up, and right front again. So you see these pieces still in the same position, same orientation. We need to rotate again, right front, right back, back, left back, up, and right front again. And the piece is correctly oriented now. Now we need to find the piece which is blue and orange and place it in here. This is the one. Once again, this piece is placed in the correct position, but we need to rotate it. So with the three pieces to preserve in the down and left position, we want to rotate it. Now the algorithm I gave you is rotates the piece anti-clockwise. We can perform the algorithm in the opposite way, so we rotate clockwise. Otherwise, we have to do it twice. So this is right front, up, left back, back, right back, right front, and the four pieces are in the correct position and correctly oriented. Once four centers are placed and correctly oriented, we want to do the same with the centers on the top, keeping the fixed centers down. We can just move the layers on the top and place every center in the correct position. For example, we want red here. And then we want the purple in here, which is easy. And the pink in here. Now we want to rotate them to orient them correctly. We will use an algorithm that keep one center fixed, and we rotate all the other one clockwise. So with the center to preserve in this position, we perform and this and this to rotate. We perform this algorithm 3 times. Front, right, up, left 1 time, front, right, up, left, second time, front, sorry, right, up, and left for the third time. How do you see? We have rotated these 3 pieces. Now every center is correctly placed and correctly oriented. Usually you need to do this algorithm more than once, but you can work it out. When you try to fix the vertices, you may end up in a situation where every vertex is in place apart from the last 2. In this case, for example, these 2 vertices are swapped, and there is no way to swap them. We have only 3 cycle vertices, and with a 3 cycle you cannot swap 2 of them. This is a parity, it cannot be fixed. It is due to the fact that the color on 2 faces is swapped. This should be the yellow face and this should be the purple face. There is no way to tell from the beginning if you're doing something wrong. This is why it's a parity. A parity is when 2 faces or 2 pieces are identical. You can tell them apart, so you misplace them. So the easy way to fix this parity is just to recognize that this is the yellow face and this is the purple. So we rotate by 180 degrees this face, and then we start replacing all the centers back again till we place all of them, and we get in a situation where we know the parity is not there anymore. Once we have fixed all the centers, the next step is to fix the vertices. We do that with a 3 cycle, which moves vertices on the same line. For example, in this case, we want this vertex to be here. This is light purple, yellow, white, and pink. So we want this to be here. When we perform the 3 cycle, this color on this side will go on this face. And the 3 cycle will move this vertex to this place, this vertex to this place, and this vertex to this place. The algorithm is very simple. It's right, left, right, left. As you see, the vertex goes in place and all the centers are unchanged. Our goal is to place 3 vertices in a line correctly oriented. So we did this one. The next one will be this one. We want to place this vertex here correctly oriented. However, if we move this vertex here, it won't be correctly oriented. We want this color to be opposite to this color. To do that, we need a setup move. We do that. In this case, we have the pink, and pink are opposite. So when we move this vertex here, it will be placed correctly. However, this one is already in place and we don't want to move it. So with a setup move, again, we remove it from here. And we perform the algorithm, which is right, left, right, left. We undo this setup move to replace this vertex in its original position, and we undo the setup move we did to orient this vertex correctly. And now we have two vertices in place. Now we have two vertices correctly placed. We want to place this one to have three vertices in a line. This vertex is here, but this color is not opposite to this one. So we need again a setup move so that this color is opposite to here. Once again, we don't want to remove this vertex which is already in place. So we do another setup move to swap these two vertices. This one is already in place. So by doing this, we will remove from its position, but it's not important because our goal is to have three vertices in a line. So we do a setup move. We perform algorithm right, left, right, left. We undo the setup move, so we have this vertex back in the correct position, and we undo the original setup move, and we have at this point three vertices: this one, this one, this one, correctly placed, correctly oriented in a line. Now that we have three vertices correctly oriented and placed, we want to do the same with the three vertices left. First of all, we place them in the correct position. We want this vertex to be here. So we perform our algorithm right, left, right, left. This vertex goes in place. This is in its correct position, although it is not correctly oriented, and also this is in the correct position. As you see, this time there is no parity. Now that the three vertices are in place, we want to orient them correctly. I will show you an algorithm which keep this vertex unchanged and rotates these two vertices, one clockwise and the other one anti-clockwise. The algorithm is very simple. We perform two setup moves so that the vertices go on this side. We perform the algorithm to cycle them, and we undo the setup move. Then we need to replace the vertices which was here. We move here back to its position. So again, this vertex has to go here, and we do left, right, left, right. This vertex is back in its position. It has been rotated. This vertex has been rotated by 90 degrees, and this vertex has been rotated by 90 degrees. We perform it again, the setup move. Right, left, and do the setup move. We replace the vertex back here. Once again, this is unchanged. These two have been rotated. By doing that, this vertex is now in its correct position and orientation. So if we turn the cube, we can apply again our algorithm and rotate these two vertex till they are correctly oriented. Okay, now we are almost done. We have this vertex is correctly oriented, and we need to rotate this vertex twice. We do our setup move. We perform the algorithm. Right, left. We undo the setup move. We replace the vertex in its original position. This vertex has been changed, while these two have been rotated, this one clockwise and this anti-clockwise by 90 degrees. We perform our algorithm once again. We don't want to change this vertex, we want to rotate these two. So we perform the setup move. We perform our algorithm. We undo the setup move. We replace this vertex back in its original position. Left, right, left, right. This is unchanged. These two have been rotated and now are correctly oriented. Now all the vertices in our puzzle are correctly oriented, and we are ready for the next stage. The next thing to do is to fix the triangles. To do that, I use three different algorithms. This algorithm will swap some triangles, leaving all the centers and vertices unchanged. The first algorithm will swap two couples of triangles. We swap this triangle with this one, and this triangle with this one. It is basically made of two jumbling moves, one right and one left in sequence. We start from the right jumbling move, up, down, 180 degree, down, up, and then we perform the left jumbling move, up, down, 180 degrees, down, up. How do you see? The pink is here, orange, white, and purple. The second algorithm will swap this triangle with this one, and this triangle on the same face with a triangle on the up face. It's very simple. We do front, right, front, right, front, right. Do you see? The two white come here, and the two up and left face triangle are here. We have also the symmetric algorithm of algorithm 2, which we swap this two triangle with this one and this one. It is front, left, front, left, front, left. These are the two orange swap with these two. The third algorithm is a 3-cycle. You will move this triangle here on the top, this triangle here on the same face, and this one will go on the front here. It is very simple. Back, left up, left down, left up, back, up, back, left up, left down, left up, back, down. As do you see, the white is going here, the triangle that was here is now here, and the triangle that was here is now here. Now let's see how to use our algorithm to fix the triangles. The first thing to do is to fix the easy triangles using the algorithm we have. For example, this light green is one face apart. This means we can use the algorithm 1. We can swap this one with this one, and this triangle with this triangle. So we need a setup move to put this triangle in place such that it will go here. And then we perform the double juggling move, which is up, down, front, down, up. And then again this diagonal, up, down, front, down, up. We have the green triangle in place, and we need to undo the setup move. Other things, easy things to do is to place this triangle, red triangle here. So we want this triangle to be down. We use a setup move. We perform the 3-cycle algorithm, which will take this triangle here, this here, and the red triangle on the correct face. This is back, up, down, up, back, up, back, again, up, down, up, back, and up. Then we do the undo the setup move. We can keep going like that till most of the triangle are fixed. Other example are, for example, the white. We can 3-cycle the white to put it on this face, and so on. When we keep doing that till we get to a point where we have very few triangle out of place, kind of 5 or 6 triangle. For those one, then I will show you how to fix them. And the point is that there is always an easy way to swap any triangles on the cube. And once you can swap 2 triangles, then you can solve the cube just by swapping 2 at a time. There are a few cases, and I'll show you all the cases. Once almost all the triangles have been solved, you are left with very little triangle out of place, then you can finish off the puzzle. As I said before, you can do that if you know how to swap any 2 triangles. So there are 3 cases. The first trivial case is when the 2 triangles to swap are on faces with join at a vertex. In this case, use the algorithm 3, which is the 3-cycle. So in this case, we need a setup move here. This white triangle will go here, the white triangle here will go here, and the yellow will go here. So back, up, down, up, back, up, back, up, down. Sorry. need to do the last one because it was already in the setup move. As you see, the two triangles are swapped. The second case is when we want to swap two triangles which are on faces which are next to each other. Actually, we want this triangle to be here. We are unlucky this time, but this is not a problem. We can just move it to this place with a setup move. We want to move this triangle here, and then we go to back to the previous case. We cycle on this face. So we use algorithm 3, and we do front, right, front, right, front, right. Now we want the red triangle to go to this place so we can put it back on this face. Since this triangle with the 3 cycle will go here, we need again a setup move, and we perform the 3 cycle, which is back, up, back, down, front, up, sorry, up, back, back, up, back, up, back, down, front, up, back, back, and then up, but we don't really need it because we have to undo the setup move. Now we are ready to take these two triangles here, but we want the yellow to go back to its original position. So we need to remember we did a setup move before. And we apply the algorithm number 2 again, which is front, right, front, sorry, right, right, front, right. We undo the setup move. We are back to the previous case in which we have to swap these two triangles, which is simply a 3 cycle. Up, back, up, back, down, front, up, back, and we don't need the last one because there was a setup move, and we are done. A third case is when the two triangles we want to swap, they are one face apart. We want one of the triangles, at least one of the triangles, to be next to the edge of the common face. If the triangle here, we can always rotate it in position. So the idea is that we move this triangle on the top with this simple move, and then we cycle. We cycle and we put this triangle here, which is very easy. Back, up, back, down, front, up, back, back, up, back, up, back, down, front, up, back, back, up. Once we have fixed this triangle, it can be in place, and then the only thing left to do is simply to cycle and swap this two triangle, which is easy. This triangle will be here, will go here. Sorry, this triangle will go here, this will go here, and the white will go in place, which is very easy. Back, down, front, up, back, back, up, and it is sorted. A last case is when the two triangles we want to swap are on opposite faces. I don't even consider this is a case. This is just case one applied twice. So the idea is very simple. I swap two triangle here, I swap two triangle here, and then I swap two triangle here, and I'll sort it. So first of all, we take the white triangle here, which is easy. The white will go here, and this will go here, and this will go down. I apply the 3 cycle. Now, I will put, now that I've done this, I will put the white triangle here and the gray here, which is so white will go to white, white will go here, and gray will go here. Apply the 3 cycle. It's a bit long, but it's not difficult. And now we are in a situation of case 1, where we have two triangles to be swapped on faces which are next to each other. So we do that. This triangle will go here, this will go here, this will go in place. And it is sorted. So I've shown that I can swap any two triangles on the cube, and by doing so I can solve it. Thanks for watching.